Hello everyone, in this video I will show you how to sense colors using TCS230 color sensor and Arduino. For this project you need color sensor, external power supply for Arduino. Next you need a Arduino board, and you can use any Arduino board which you have. Then we need few connecting cables to connect the Arduino board with the sensor module. Then we need some different type of color papers or any colorful object which you want to sense. Then we need RGB LED and few resistors for connecting RGB LED with Arduino. So this is my connection diagram. If you want to use some different pins, then just update the macros associated with the pin numbers in the sketch file, which can be downloaded from the links given below in the description. This is my setup. The TCS230 sensor is present inside this black box. I choose this black box to minimize the effect of IR rays and the unintended reflection, as black surface will absorb all radiations. Now let's see the demo. I will test different color papers with the sensor, and the RGB LEDs is used to generate the same color which is detected by the sensor. So let's start with the red color paper. I insert the red color paper inside the box, and as you can see the red LED turns on, indicating that red color is detected. Now I will do the same thing for the green color, and the green color is detected and the green LED turns on. Now let's take the blue color. Blue color is detected and blue LED turns on. Now let's take the yellow color. Yellow color is detected and RGB LED turns on in ratio which displays yellow color. Now let's take the light green color paper, and this is detected and light green LED turns on. Now we take dark yellow or orange color paper, and this is detecting and the RGB LED turns on in the ratio which displays orange color. Now once again take the red color paper, and it works fine. Now it's time to see how this color sensor works. TCS230 sensor senses the light with the help of 8x8 array of photodiodes, which means we have total 64 photodiodes in the sensor modules. Out of these photodiodes, 16 photodiodes are used to sense the red color as they have the red filter, 16 are used to sense the green color as they have the green filter, 16 are used to sense the blue color as they have the blue color filter, and the rest 16 diodes don't have any filter, and they are known as clear photodiodes. The sense light is converted into current, and then a current to frequency converter is used to generate a square wave output depending upon the light received on the photodiodes. Pin number S2 and S3 are used to select the photodiode type, as we cannot activate all the photodiodes at once. Output frequency scaling feature is also present in this sensor, and S0 and S1 pins of these sensors can be used to scale down the output frequency of this device. This feature is really important when we are working on a micro which cannot handle high frequency signals. This graph is the spectral responsivity curve of this sensor. So as you can see clearly that in the infrared region of the spectrum, all the red, green, blue filters are giving the same response, which makes this sensor almost unusable if the infrared signals are present in the environment. That's why I use the black box to prevent the infrared signals. Another approach to prevent the infrared rays is to use the IR filters to block the IR rays reaching the sensor. But I think they are quite costly, and we cannot find them easily in the market. So I would suggest either to use a black box with this sensor, or you can use the TCS34725 color sensor, which has inbuilt IR blocking filter inside it. As you can see in this graph that that for IR rays the response of the red, green and blue values is almost negligible. Now coming to the calibration part, take different type of papers whose colors you want to sense with this sensor and measure the response of RGB component received using all different papers, and note them at some place like I did in Excel sheet. Obviously you can modify to store the calibration values in EEPROM and then directly fetch these values from EEPROM into your code. Now we are going to use these values next time when we want to detect color with some threshold values, as I did in my program. Now let's come to the program part. The program is very simple and can be downloaded from the links given in the description tab. This is the flow diagram of my program, which will help you understand the program easily. First of all, I initialize all GPIOs and serial communication. Then in the next step, the frequency is scaled down to 20%. In the next step, it's time to read the RGB values. You have to read the RGB value step by step. Like first you will read the red value, then you will read the green value, and then you will read the blue value. So for reading the red value, select the red filter and measure the pulse width using pulse in functions of Arduino and store the averaged value into the red data variable. Now we are going to do the same thing for green and blue color. After this, compare the red data, green data and blue data values with the values obtained at the calibration process, and based on that turn the RGB LED to display that particular color. Now coming to the conclusion part, this method works fine. And for those who want to do some more experiment, they can use convex lens to increase the range of the sensor and use the red, green and blue high intensity LEDs to illuminate the surface of the object to get better results. I am also working on a way to increase the range and reduce the time taken to do the calibration process. Once the method is successfully completed, I will definitely post the video here. Till then, bye bye. And if you like this video, press the like button and share this video with your friends. Please do subscribe to my YouTube channel and stay updated. Thank you.